Dissociation is the separation into ions. So here we have sodium chloride and it's dissociating in water, and we have sodium ions and chlorine ions. If we were to write the dissociation equation for sodium chloride, it would look like that. You have your solid, it breaks up into sodium and chlorine ions. Make sure that you put the positive and negative signs when you write the dissociation equation, or it will be counted incorrect. When it's in its dissociated form, ionic compounds are able to react with each other. When they're not dissolved or dissociated, the ions remain more attracted to each other than to the solvent. You're going to use solubility rules to figure out what dissociates and what doesn't. An electrolyte, we have strong, weak, and non-electrolytes. An electrolyte is simply a solution that can conduct electricity due to the presence of ions in solution. Strong electrolytes have lots of ions in solution, so they conduct electricity very well. They have lots of ions because they dissociate 100%. Weak electrolytes, some molecules dissociate, some just dissolve. So we have ions and molecules, so it glows weakly. And non-electrolytes, the light bulb's not on at all because it just dissolves. We do not have ions in solution. No ions, no electricity flowing. So to figure out if something breaks up, you need to first ask yourself, is it an acid or a base? If so, strong acids and bases break up in solution 100%. Weak are going to stay together mostly. So your strong acids, there's 7 of them, are nitric, perchloric, chloric, sulfuric, hydrochloric, hydrobromic, and hydroiodic acid. Your strong bases are group 1A hydroxides as well as calcium, strontium, and barium. If it's a covalent compound, not including acids such as water, it's going to stay together. And if it's not an acid or a base, that means it's a salt, and you're going to have to follow the solubility rules. So your solubility rules need to be memorized. Insoluble and slightly soluble are basically the same thing. So first, all compounds in group 1A or ammonium are soluble, no matter what the anion is. So if you had sodium whatever, it's soluble. Or ammonium whatever, it's soluble. All nitrates, chlorates, perchlorates, acetates, and nitrites are soluble no matter what the cation is. So whatever nitrate, soluble. All chlorides, bromides, and iodides are soluble except silver, lead 2, and mercury 2. So silver chloride's not soluble, while iron chloride would be soluble. All sulfates are soluble except 6, silver, lead 2, mercury, calcium, strontium, and barium. Everything else is assumed to be insoluble unless it begins with group 1A or ammonium because of rule 1. So before we can figure out if these break up into ions, you need to ask yourself, is it an acid, a base, or a salt? So sodium chloride is not an acid because it doesn't start with hydrogen. It's not a base because it doesn't end in hydroxide. It's not molecular, so it's a salt. According to the solubility rules, it breaks up into sodium and chlorine ions because sodium's in group 1A. Mercury chloride, or mercury 1 chloride, isn't an acid, it's not a base, it's not molecular, so it follows solubility rules and it does not break up because all chlorides are soluble except silver, lead, and mercury. Pause the video and try the next ones on your own. Magnesium hydroxide does not break up because it's a weak base. Acetic acid does not break up because it's a weak acid. Potassium acetate breaks up because it's a salt that has group 1A and it has acetate, which all break up. Potassium hydroxide is a base. It's a strong base, meaning it breaks up. Silver bromide is a salt, but it does not break up because all bromides break up unless it's silver, lead, or mercury. And magnesium sulfate is a salt, and it breaks up because all sulfates are soluble except silver, lead, mercury, calcium, strontium, barium. Go ahead and do the following on your own. Restart the video when you're done. We'll go over these in class. You can double check yourself that lead 4 sulfite should have been insoluble. A precipitation reaction is simply a double replacement reaction in which one of the products forms a precipitate. A precipitate is a solid that's formed from a solution. So you have two liquids and a solid drops to the bottom. So you need to be able to predict the products of these reactions and decide if it's insoluble, we're going to put an S for solid, and if it's soluble, we're going to put a Q for aqueous, meaning it breaks up. All of these are double replacement reactions, so the outside ions go together and the inside ions go together. So in A, we had potassium and carbonate go together, and we had calcium and hydroxide go together. Make sure that your positive ions or cations are first, because positive goes before negative, and then put them together how they go together. Potassium and carbonate go together, K2CO3, because of the charges. And calcium and hydroxide go together because calcium's a +2, while hydroxide's a -1. Potassium carbonate is aqueous because all potassium or group 1A salts are aqueous. And calcium hydroxide is a base that is insoluble, so that would be a solid. Go ahead and pause the video and try B and C on your own, predicting the products and deciding if it's soluble or not. Okay, for B, you should have got lead 2 chloride and sodium nitrate as your products. Lead 2 chloride is insoluble because all chlorides are soluble except silver, lead, and mercury. And sodium nitrate you should have got was soluble because all nitrates and all group 1As are soluble. For C, you should have got sodium chloride and barium sulfate. Should have gotten that sodium chloride is soluble because it's in group 1A, and barium sulfate is insoluble because barium's one of the 6 insoluble sulfates.